Okay, so let's talk about solving nonlinear inequalities. Nonlinear just means inequalities that involve functions that are quadratic, powers bigger than 2, or a linear inequality would be something just like negative 10x plus 16 greater than or equal to 0. Pretty much just solve it like an equation, isolate the x. Remember to, if you multiply or divide by a negative number, you need to switch the sign. So if it was greater than, you would switch it to less than. But a nonlinear inequality, something like this, x squared minus 10x plus 16 is greater than or equal to 0. These can be tricky. These are one of the most missed types of questions in algebra. And I understand why. If you think of an equation, the equivalent equation would be x squared minus 10x plus 16 equals 0. How would we solve that? Well, looks like we could factor this. This factors into x minus 2 times x minus 8 equals 0. And many of you probably know, once you get it to here, your solutions, your answers for x would just be 2 and 8. And why is that? It's because if you have something times something, x minus 2 times x minus 8, if something times something equals 0, it means either x minus 2 is equal to 0 or x minus 8 is equal to 0. And that's how we get our two answers of 2 or 8. Okay, it's called the zero product property, right? If two things multiply together equals 0, one of them has to be 0, right? So how do I, now back to this inequality, it would seem to make sense. I should solve this the same way. I should start by factoring x minus 2 times x minus 8 greater than or equal to 0. But here's where a lot of people get the wrong answer because they treat it like an equation. It would seem plausible, since how we got the two answers here was by setting each individual factor equal to 0. It would seem plausible. If you're taking notes on watching this video, perhaps don't write this down, what I'm going to write next, but it seems plausible that if you have x minus 2 times x minus 8 is greater than or equal to 0, it means either x minus 2 is greater than or equal to 0 or x minus 8 is greater than or equal to 0, right? I'm going to put question mark. Well, let's see. Here, if you move the 2 over, you get x is greater than or equal to 2, or x is greater than or equal to 8. So first of all, that's a little confusing on what would our answer be. If you think on a number line, here's 2, here's 8. The numbers greater than or equal to 8 are over here. The numbers greater than or equal to 2 are over here. But what am I going to write as my answer? And here's the bigger thing. With this, if you solve the problem this way, wouldn't you agree it would seem like something less than 2 should not be part of our answer, right? If we solve it this way, it does not look like something smaller than 2 is going to be part of our answer. But what's the ultimate test? Let's pick a number, bigger, less than 2. What about x equals 0? If I plug x equals 0 back into this original problem, or even up to here, right? It's probably easier to plug it in here in this case. If x is 0, what does this function give me? It gives me 16. And 16 is greater than or equal to 0. So actually, numbers less than 2 are part of my solution. But if you solved it this way, namely the same way you would solve an equation, obviously that's not going to show up. The point I'm trying to make here is you do not want to solve an inequality this way. This is going to lead you down the wrong road. Okay. Instead, if you're wondering why that's true, here's why. When we say x minus 2 times x minus 8 is greater than or equal to 0, what do we mean by greater than or equal to 0? We mean basically a positive number, right? Or 0. What are the ways you can multiply two things and get a positive number? Either they can both be positive, or they could both be negative, right? Two things could both be negative, multiplied together gives you a positive. But the claim we're making here, when we say x minus 2 is greater than or equal to 0, we're saying positive, right? And we're saying positive. So we're only considering the case when both of these factors are positive, and we're not including the case when they're both negatives. There would be a way if you address that too, the situation where they're both negative, where you could somehow combine these two answers and get the correct answer, but there's a way better way. So let me just start over. When you get to here, x minus 2 times x minus 8 greater than or equal to 0, here's what I want to train you to do. Do not set each of them greater than or equal to 0. Instead, you're going to draw a number line. The numbers that are going to go on the number line in this case are going to be 2 and 8. Those are the numbers that make each factor equal to 0. And then what we're going to do is we're going to pick test numbers in each of the regions. Pick test numbers. So something bigger than 8, any number bigger than 8. You can choose 9, you can choose 10, you can choose 100 if you want to. Something between 2 and 8, take your pick. How about I use 5? Something less than 2, well, we already tried 0, but we'll use that again. And what you're going to do is plug these numbers in. You can plug it in back here, but I think it's easier to plug into the factored form. All I care about is whether you get a positive or a negative. You don't actually have to figure out the number. So for example, let me start over here with the 0. I plugged it in here and got 16, but if I plugged in 0 here, 0 minus 2 is a negative number. 0 minus 8 is a negative number. But what happens when you multiply a negative by a negative? You get a positive number. So what this means is if I use any number less than 2, this expression is going to generate a positive number. How about 5? 5 minus 2 is now positive. 5 minus 8 is negative. A positive times a negative gives me a negative. And if x equals 10, 10 minus 2 is positive, 10 minus 8 is positive. A positive times a positive is a positive. Since we wanted the positive numbers here, my answers are going to be anything less than 2, including the 2, because that would make it equal to 0, and anything greater than or equal to 8. So you can write this answer as x is less than or equal to 2, or x is greater than or equal to 8, or you can use interval notation. An interval notation, we just go left to right. What's the number furthest to the left that is part of our answer? We want to go all the way to negative infinity. And then we want to get all the answers from negative infinity until we get to 2. Since we want to include the 2, we use a closed bracket here. If you think about it, you could never really get to infinity. So we're going to use a soft bracket, parentheses on infinity. That means you're never really going to get to that number. In fancy math notation, another name for or is union. That means that's a union. Set notation. That means or. And then we want the numbers from 8, including all the way to infinity. So as we move into calculus, this is going to be how you're going to want to express your answers in interval notation. Okay. So this technique is so important, and even something simple like this is so easy to make the mistake and try to do it like you would an equation. Namely, if this was x squared equals 49, what I would do is just take plus or minus the square root, and I would get x equals plus or minus 7. If you try to do that here and say x squared is greater than 49, and then try to say something weird like x is greater than plus or minus 7, once again, there's like a little bit of an ambiguity. What do you mean? What numbers are greater than or equal to plus or minus 7? So don't want to do that. Instead, for these, you definitely want to factor. And as soon as you get it factored, whenever you have multiple factors and it's an inequality, number line. So I'm going to have -7 on here, +7. That's a -7. So now I want to pick some test numbers. So I might pick like -10, Between -7 and 7, how about just 0? And maybe +10. I like to go from left to right. -10 plus 7 is negative. -10 minus 7 is negative. Negative times a negative is positive. 0 plus 7 is positive. 0 minus 7 is negative. Positive times a negative is negative. And if x is 10, both of these factors will generate positive numbers. This time, we still want positives because it's greater than 0, but we don't want to include, because it doesn't have the equals, we don't want to include these endpoints here. So we want these numbers, all the numbers less than -7, which in interval notation, -infinity to -7 parentheses, because I don't want to include the -7, or parentheses 7 to infinity. Okay, let's try this one next. So with these inequalities, you can see when I'm doing my number line, I have everybody on one side, and I always want to see, when I write positive or negative, I mean greater than 0 or less than 0. So when you have a nonlinear inequality, you want to make one side 0. So that means we're going to move everybody over. So if I have x cubed less than or equal to 14x plus 5x squared, first step is to move everybody over to one side. Let's make this x cubed. Let's put the minus 5x squared next. Minus 14x less than or equal to 0. Each term has at least one power of x, so let's factor that out first. Factor this completely. This factors into x minus 7, x plus 2. And now, when you have all these factors multiplied together and it's an inequality, now you want to use the number line. Think of the straight line there, right? So now we're going to want -2 on our number line because that makes that factor equal to 0. 7. And what makes x equal to 0? Just 0. So we'll have 0 on this number line. Now we've got 4 regions. So let's pick some test numbers here. Something less than -2. How about -10? Between -2 and 0, -1. Between 0 and 7, how about 1? Bigger than 7, how about 10? And what you should do now, you might want to pause the video, is just to make sure you get the right signs. Is you have to run these numbers through every single term here. This is why it matters. Don't really care about the numbers. Just say positive or negative. -10 here is negative. -10 minus 7 is negative. -10 plus 2 is negative. 3 negatives multiplied together gives you a negative. If x is -1, that's still negative. That's still negative. But -1 plus 2 gives you a positive number. 2 negatives times a positive would generate a positive number. If x is 1, this one becomes positive. That's still negative. That's positive. Those 3 give you a negative. And if x is positive 10, all 3 of those factors are going to be positive. Then we want to look and see, okay, this time, since it's less than or equal to 0, we want the negatives, and we want to include the numbers themselves. So these will be closed circles, and we want the negatives. So we have this range of numbers and all of these numbers. Interval notation from -infinity to -2 bracket, or bracket 0 to 7. Okay, what about if you've got a fraction? Well, the same strategy is we're gonna use here. We still want to factor everybody. So x squared minus 1 is a difference of squares. x plus 1, x minus 1. The bottom x squared plus 8x plus 15 factors into x plus 3, x plus 5. I mean, and if you think about it, trying to find out where a fraction is greater than or equal to 0, it also depends on the signs, right? In other words, you know, if the top is positive and the bottom is negative, I'm going to get a negative number, right? So we have to test all of these factors. So we're still going to use our number line. And we're going to put all of the so-called key numbers, the numbers that make each of these factors equal to 0. So we'll have, let's see, furthest to the left is -5, -3, -1, and +1. Pick your test numbers. -2 maybe here. How about 0? How about 4? And we'll start testing here. So -10, all of these factors are going to be negative, right? Negative, 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 negative. So the numerator will be positive because two negatives multiplied together give you a positive. The denominator will be positive. A positive divided by a positive is going to give you a positive there. When x is -4, the only factor that's going to change is this one here. -4 plus 5 gives you a positive, which makes the denominator negative. My numerator is positive. This will come out to be negative. When x is -2, that's still positive. Now this one changes. -2 plus 3 is positive. These guys are still negative. So I'm back to a positive over a positive. X is 0. Now 0 minus 1 is negative, but 0 plus 1 is positive. My numerator is negative, denominator is positive. The quotient will be negative. And you may have noticed this. This isn't always true, but the way a lot of times your biggest number here, everybody's going to be positive. Be careful. There's ways of making a problem so this isn't always positive. So in this case, they'll all be positive. Now, one thing we have to watch out for. Greater than or equal to 0 means I would normally want to include the numbers themselves, right? And I will include 2 of the numbers, but the other 2 I will not include. So the -1 and the 1 will be included in my answer, but the -3 and the -5 will not be, even if it says greater than or equal to. Why is that? Well, there's something we'll talk about later called the domain of a function. But notice that if x equals -5 or x equals -3, I'm going to get 0 in the denominator. And we're not allowed to have 0 in the denominator of a fraction. So just make a note here. Note x equals -5. X cannot equal -5 or -3 because they make the denominator equal to 0. So you got to watch out for that on these types of fraction problems. Everything else is the same in that since it's greater than or equal to 0, we want the positive numbers. So we're going to want all of these numbers, and these numbers. In interval notation, from -infinity to -5 parentheses, or parentheses -3 to -1 bracket, because we want to include that, or the numbers from bracket 1 to infinity. Okay. Now, as I said before, when you do these inequalities, you do want to have one side equal to 0. And then the other thing that you can't do, and this might need a little explanation, if I was dealing with the equation 3x plus 2 over x minus 4 equals 5, what I would do is multiply both sides by x minus 4 to get rid of the denominator, right? That would cancel here. You would end up with 3x plus 2 equals 5 times x minus 4, and you would go on and find your solution. So a lot of people wonder, why can't I do that here? Why can I not just multiply both sides by x minus 4? And here's the answer. We do not know what x minus 4 is. We do not know what x is yet, right? So we don't know if this denominator is positive or negative. Because what's the one thing we have to worry about with inequalities? If we multiply by a negative number, we're supposed to switch the sign. Because we don't know what x is yet, we can't multiply by x minus 4 because we might be multiplying by a negative number. So you don't want to do that here. So what does that leave us with? We have to move this 5 over. Leave some room and make the right side equal to 0. And what we're going to need to do is do a common denominator. We're going to have to multiply this minus 5 top and bottom by x minus 4. So then we're going to have 3x plus 2. And then if we distribute this 5, minus 5x plus 20 less than or equal to 0. 3x minus 5x is negative 2x. 2 plus 20 is 22. And now we've got it basically as far as we need to take it. I suppose you could take out a 2 here, but at this point, we're ready to use the number line. And what are our key numbers? Well, what makes the denominator 0 is 4. What makes the numerator 0 is 11. And let's take care of this right now, like we saw from before. You cannot have x be 4, or you're going to be dividing by 0. So let's just acknowledge that x cannot be 4. In fact, why don't we go ahead and take care of it? Let's put an open circle on this. X could be 11, because if x was 11, the numerator would be 0, and that would make this whole fraction equal to 0. Okay, we'll pick some test numbers. 7. How about 100? X is 0. I get 22 over negative 4. That's negative. X is 7. That's going to be positive on the top. No, it's going to be negative on the top, right? That's negative 14 plus 22. Negative on the top, positive on the bottom. Oh, that's positive. Never mind. Negative 14 plus 22 is positive. Positive over positive is positive. X is 100. There we go. This is going to be negative now, right? X is 100. That's negative 200 plus 22, and that's going to be positive. So this is negative. This time we want the negatives. So it's going to be those numbers and those numbers. Negative infinity to 4, not including, and then from 11 to infinity, including the 11. Okay, I'm going to skip to these last two problems here. One thing you might start to notice. Well, let's solve this first of all. Let's see what happens here. So this, no fractions here. Let's just factor this thing. Looks like I can take out an x squared first. And then x squared minus 6x plus 9 factors into x minus 3, which you could write as x minus 3 squared. And everybody's factored. It would be time to use the number line. My key numbers would be 0 and 3. And if I pick test numbers, and maybe some of you are spotting this now, what happens if I plug in negative number and square it? That's going to be positive no matter what, right? -1 minus 3 is negative, but if I square that, that's going to be positive no matter what. This is going to be positive when x is -1, and certainly when x is +1, both of those are going to be positive. These are always going to be positive, right? Because I'm squaring. These will always generate positive terms. And so what are we looking for here? We are looking for the positive numbers, and we're allowed to include the numbers. That means I want all of these numbers, all of these numbers, all of these numbers, including the 3s and the 3 and the 0. So the best way to describe this is any number, Any number will work. Any number will work. Now in interval notation, what is the whole entire number line? That is everything from -infinity to +infinity. And I wanted to show you this example because some of the problems we've done, if I look at problems 3 and 4, which maybe some of you picked up on this, there seems to be a pattern where it goes negative, positive, negative, positive, positive, negative, positive, negative, where the signs just continually switch back and forth. And you might think that that's going to happen every single time. Clearly, this doesn't happen here, right? The signs don't necessarily switch. You also might be thinking it has something to do with the power, and you would be absolutely right. Okay, so keep that in mind. And then finally, one more inequality, just to remind you that what happens if it doesn't factor? Well, I would actually say this does factor, but how would I get that to factor? There's no factors of 2 that add to -6. But what would you do? I know I said be careful with trying to solve this as an equation, but how would you solve this equation if you didn't factor it? If it doesn't factor, we could use the old quadratic formula. -b plus or minus b squared, square root of b squared minus 4ac, all divided by 2a. So I would have negative of -6 plus or minus the square root of -6 squared minus 4 times 1 times 2 over 2 times 1. That gives me 6 plus or minus 36 minus 8 is 28. Remember, we try to pull out perfect squares from square roots if we can. 28 happens to be 4 times 7. So the square root of 4, that's going to come out as a 2. So this is x equals 6 plus or minus 2 root 7 over 2. And then if you notice that this 2 divides evenly into both of those numbers, it's often nice to split this up and make this 6 over 2 is 3, plus or minus, here the 2's cancel, plus or minus root 7. So how does that help me here? I know we think this doesn't factor, but in fact, it actually does factor. It's just a little bit strange looking, right? Now that we know these are the solutions to the equation, we could argue that this thing factors into x minus 3 plus root 7 times x minus 3 minus root 7, right? Because those are the roots. So we would be using a number line, and what would be on your number line would be, the smaller number would be 3 minus root 7 is your root, and the other one would be 3 plus root 7. You could still pick test numbers here. I know it gets a little bit hard to think about the positive and negative, so that's why sometimes you notice I don't even make it close. If I use like -100, that's going to certainly be less than 3 minus the square root of 7. What's a number between 3 minus root 7 and 3 plus root 7? How about just 3? And then how about I choose like 100 over here? If I do -100 minus this little number, clearly that's going to be negative. And if I do -100 minus, that's not going to be a very big number either. That's also going to be negative. So this is going to give me a positive number. Okay, if I plug in 3 minus 3 plus root 7, if you distribute that negative, the 3's are going to cancel. You're going to end up with a negative root 7, so that'll be negative. If I put 3 in here, 3 minus 3, that'll cancel. And if I distribute that negative there, that would be positive. So this will be a negative number. And if you do 100, 100 minus that, 100 minus that, both of those will be positive. Less than or equal to 0 means we're going to want these numbers here. So my solution would be bracket 3 minus root 7 to 3 plus root 7. Okay. So hopefully you can see the big tool, right? If you have a nonlinear inequality, factor it if you can, even if you have to force it, and then automatic, you want to use the number line and pick test numbers. There you go.